What is going on here?
All right, I'm going to do 67. I'm going to rewrite it because you definitely need more room. So, if you want to go ahead and try it on your own, you can.
No, I just have a question for you on this.
Okay. When I'm done with these three, I can help with corrections. All odds, yep. Because we're going to obviously have the whole period right now. So, how many mini fractions are in this problem? How many mini fractions are within the larger? Two. And their denominators, one has a denominator of x plus h squared. The other has a denominator of x squared. So they currently have no overlapping factors already. So the least common denominator of those two denominators is just going to be the x plus h squared and the x squared. So you're going to multiply by that over itself. So in the numerator, given that the numerator is a binomial, that has to be distributed. So when I distribute to the first fraction, what cancels? The x plus h squared, leaving just x squared, right? Mini fraction gone. When I distribute to the next term, what cancels? The x squared, leaving just the minus and then the x plus h squared.
I never got that until like just now.
Good. I'm glad I did it the second day. Good. So mini fractions are gone, and then your denominator is just h, x plus h squared, x squared. There's nothing to really do in your denominator because that's not where the mini fractions were. So you just kind of let that be.
You still have to multiply by x plus h squared and x squared. Get the h.
Right, because you're multiplying the numerator and the denominator by the same thing, so that you're technically multiplying by one, changing the appearance but not changing the value. So then in our numerator, we just have to clean it up. So I'm going to keep the x squared, keep the minus sign, and I'm going to square out the x plus h. That's a shortcut. X squared plus 2xh plus h squared over that denominator that I'm doing nothing with. And then I have to distribute my negative. So the x squared minus the x squared will cancel. Then I'm going to have a minus 2xh, and I'm going to have a minus h squared over this obnoxious denominator. And then once it's all simplified, you do want to explore factoring again in the event that something else can be simplified. And the numerator is factorable by GCF. What can I take out? Negative h. Negative h will leave you with 2x plus h over h, x plus h squared, x squared. And then your h's cancel.
So you have a negative.
Negative, parentheses, 2x plus h over x plus h squared, x squared. So again, I picked one of the three hardest, I think, on the back. By the way, the complex fraction part was done and over with after the first step. Everything thereafter is just tedious Algebra 2 work. Okay? The complex fraction part really was done and over with way up top. Tommy, how are you feeling with that?
Pretty rough.
Pretty what?
Pretty rough.
Okay, we're going to do two more. So 67 is going to be hard. 73 is going to be hard. So I'm going to throw 73 down here and recopy. Okay, Tommy. You're the guy. The guy.
You're that dude.
How many mini fractions, Tommy?
2.
2. And right now, are there any commonalities, common factors within those denominators? Within this denominator and this denominator? Any factors that they each have that are overlapping already? That's not a factor of this one. So they're actually, it would have to be, if this was the square root of x plus h and then another root x afterwards, then they would already have that in common. But even though it's only off by a plus h, there's no common full factor yet. So if you were getting a common denominator between these two fractions in and of itself, that common denominator would be root x plus h. So whatever that least common denominator would be, that's what you multiply by in the numerator and the denominator. In the denominator, I'm not going to really have to do much. In the numerator, I'm going to distribute that, and it's going to clear these mini fractions, hence the reason this is called clearing fractions. So on the first distribution, what cancels? Which root? So when I just do this times this,
radical x plus h
is going to cancel with that radical x plus h, leaving just this one. So root x minus, and on the second distribution, listen, if you picked the right least common denominator, the denominator is going to cancel every single time. It's more about figuring out what's left over. So that denominator is going to cancel with that, and what's going to be left over is just this 1, which we don't need to write, radical x plus h. And then your denominator is just h radical x plus h. That's it. We're done. Because there's no factoring, no more simplifying, no more factoring to be done. So that one's shorter because we don't have any follow-up steps. Lydia.
I thought we can't leave radicals alone.
So that's funny. That's like once we get to calculus, rationalizing is out the window. If you're getting rid of complex fractions and that's the instruction, then just get rid of the complex fractions and that's the focus of that problem. You won't also have to rationalize. If you're ever confused on a test or a quiz, just ask me, do I have to rationalize this or not? And if it's like this type of problem and the real skill we're trying to work on is clearing complex fractions, you will not also have to do that. Yep.
So, like, for number 55, we're going to look at that one. It's like x over 3 minus 1. But, like, I would multiply each by 3, right? Like
3 on the top, 3 on the bottom.
But then, like, I feel like that's weird because then it would be like x, like the x over the 3, then I have to multiply that times 3 too. Then, like,
no, let's watch. We can do that one too. If you multiply by 3 over 3, when you distribute in the numerator, that's technically a 3 over 1. That's what you keep forgetting. We had this talk yesterday. So the 3, if you're just multiplying a fraction by a whole number, that whole number is technically over 1.
Right.
So that only gets multiplied by the numerator. So technically it becomes 3x over 3, but your 3's cancel. Are we good?
Yeah, got it.
Okay, so that's just going to be an x minus a 3 over, and I'm not going to multiply out the denominator because then I just end up refactoring. And so my x minus 3's cancel, and it's just 1/3. All right, let's do the next hardest one. Just so you know, when you do get down, so we've done 67 and 73. When you get down to the bottom here, these aren't really complex fractions anymore. Are you with me? So maybe I'll just do one of these just so you're not tripped up because I haven't really done any of these, but I somewhat expect you to just be able to do them. 79? I think 81 might be harder. In 79, you're just going to factor, cancel, and clean up the parentheses, and then it's just going to be subtraction, so you're just going to have to get a common denominator and go that and do that. But I think with 81, because they're binomials, and each binomial has its own fraction, we still have to just, what would be your first step here? What's your gut tell you in 81? If you see two binomials in parentheses next to each other, just distribute, exactly. So 2 times 1 is just 2. Here's one for the peanut gallery. What's 2 times 3 over x minus 2?
6 over x minus 2.
Very good. See, so you know that that's just over 1.
Yeah.
Okay.
I just confuse myself too much.
Okay. And then on your next one, minus 6 over x plus 1. And then, how about this last one? Negative 6 over x plus 1 times positive 3 over x minus 2. How should I write that? Andrew, I got faith in you.
Yeah. Negative 18 x plus 1 times x plus or x minus 2, or you could.
Right. Well, you don't want to FOIL it out. You see why? Well, no, because your follow-up step is going to be adding and subtracting all these fractions.
Oh.
If you FOIL that out, you're just going to have to strip it back and factor it to see what you already have in common, because now we need a common denominator. So this guy needs an x minus 2. This guy needs an x plus 1. And this one, unfortunately, needs both, x minus 2, x plus 1. So let me ask you here, this may or may not be a trick question. When I'm about to do this right now and multiply out all those numerators, what do I do with the denominator?
Cancel it.
Like just cross them all off?
Yeah.
Well, if you think yourself, yeah.
You would have to do any math with yeah, like just keep that denominator in your head.
I don't like that smile. Like, it's scary.
Well, because so if I ignore the denominator and I just multiply out all the numerators,
You Gucci.
and then I do all the addition and subtraction and combine like terms, is my final answer over x plus 1, x minus 2, or am I crossing that out and just forgetting about it totally? Yes.
Cross it out.
No.
You should just
So here's the thing. If you're solving an equation, and it's an equation that you're solving, once you get a common denominator everywhere, you can totally cross it out and totally forget about it if you're solving. If you're simplifying an expression, for example, if I said to do 1/3 plus 5/3, you don't just cross that out and tell me the answer is 6, right? So if you're simplifying an expression, that's 6/3 and becomes 2. If you're simplifying an expression, you keep it over that common denominator, whatever it might be. So yes, we can forget about this in the meantime, but our final answer does need to be over that. And I know that we like to just cross it out and forget about it when we're solving equations, and that's a good spot to do that, but it doesn't work if you're simplifying. All right, so, oh boy. 2 times all this. So I'm just going to keep the 2 there, and I'm going to do x minus 2 times x plus 1, foiling sort of in my head. It's going to give me x squared plus 1x minus 2x is going to be minus an x. And then negative 2 times 1 is going to be negative 2. There's my first term. Plus, what, Alyssa? Very good. 6x plus 6. She distributed that 6. Are you just taking it all in, Brock?
Yeah.
Okay, that's fine. And then what's my next term going to do? Maggie? Very good. She distributed the negative. And then minus 18. So I just need to now distribute that 2. 2x squared minus 2x minus 4. And then at the end of all this, I've got a 2x squared. How many x's do I have? My plus 6x and my minus 6x is a wash, so just minus 2x. And then I have a minus 22 with the 18 and the 4, plus 12, which is minus 10. Over, and now is a good time to remind myself that I do have a common denominator that this all needs to go over. But I'm not done, Faith, right? Yes, factor the top. Starting with taking out a 2. So that's just going to leave me with x squared minus x minus 5.
Where'd you get minus 10?
It
should be minus 4. The 6.
Oh, I did forget that. I did, yep. So negative 4 plus 6 is 2. 2 plus 12 is 14. 14 minus 18 is negative 4. Sorry. So when I take out that 2, oh man, it is going to be factorable now. Which is fine, because more is just going to cancel. So in that numerator, I take out a 2. That trinomial is now factorable into x minus 2, x plus 1. All over x plus 1, x minus 2. What's the final answer? 2. That is pre-calc for you. A lot of work. Final answer is 1.
Basically,
2.
the first term that the first term does itself.
It happened to appear that way in this particular problem.
Exactly.
Yeah. Not always, though.
Well, in this problem,
Yeah,
exactly what happened.
yeah.
3.
Okay, so carry on. I'll let you do some odds by yourself. Okay. If you have help, just bring it up.
For 59. Okay, so can you explain to me
Yep.
what we're supposed to find?
Finish now.
Like how we're supposed to find? We're supposed to multiply.
Okay. If I were to, like, on the side, list out your mini fractions that are within this thing, one of the mini fractions is this 1 over x, right? And the other mini fraction is this 1 over y. If you were trying to get a common denominator between the two of those, what would it be? xy. That's the least common denominator. So you multiply by xy over xy. So on the top, when you distribute this, on the first distribution, your x's are going to cancel. It'll just be a y.
How does? Oh yeah. Okay, so the x is canceled. It's just left with y.
Y plus, and then on the second one, your y's will cancel. Guys, it's way too loud.
So this just
Work
What do you TJ?
so that just becomes y plus x
over
Oh yeah, hold on.
over x plus y.
times that. Right? Because in your denominator, you don't really have to distribute because you're not clearing many fractions. And in fact, I leave it separate because now it's already factored.
Okay.
And your answer is just 1 over xy.
Okay. Thank you.
All right, so for this one,
So,
wouldn't I just be able to cancel? Look at
so I couldn't really follow your work.
yeah, because I just like do out of my 9 scribble.
But
But like this is what I got out of it after I just redid it.
So you split it up.
Yeah.
And so this and this are a wash and cancel.
So it should be 1 over 3x. Okay, gotcha.
Who's the answer key here?
Yes. Andrew's got the answer key. He'll leave it up on the front table if you want to check. Oh, yeah. Thank you.